This video is linear programming and sensitivity analysis. Example 1 talks about Chocos and Flakers. It talks about restrictions or constraints of E114 and E320, and it also talks about constraints of the number produced of Chocos and Flakers. So Chocos and Flakers have money attached to them, and therefore these are our decision variables. How many of each of these should we make? E114 has 80 kilograms available. E320 has 70 kilograms available. The constraints from marketing for Chocos is that we produce no more than 5,000 and that we produce no more than 7,000 Flakers. So we know that Chocos gives us 10 pence per Choco that we sell and 4 pence profit per Flaker that we sell. We know that E114 has a constraint of 80 kilograms, E320 has a constraint of 70 kilograms, Chocos has a restriction of 5,000, and Flakers has a restriction of 7,000. Our decision variables are C being the number of Chocos that we produce, and F being the number of Flakers that we produce, and everything will be written in terms of our decision variables C and F. Right, let's now formulate this as a problem. So our objective function says the profit generated from each Choco is 10 and each Flaker is 4, so we should have 10C plus 4F. 10 for every Choco, so 10 times the number of Chocos we produce, 4 times the number of Flakers we produce. Each Choco contains 5 grams of E114 and 10 grams of E320. And each Flaker contains 10 grams of E114 and 5 grams of E320. So we know that constraints 1 and 2 are E114 and E320, 5 grams for every E114 and 10 grams for every E320 for the Choco. For each Flaker, it's 10 grams of E114 and 5 grams of E320. Notice that the right-hand side has changed to 80,000. That's because this side is in terms of grams and the right-hand side was in terms of kilograms, and we need them in the same units. Chocos produced no more than 5,000 and the number of Flakers to 7,000. So 2 more constraints. The number of Chocos, 1 times C, must be less than 5,000. Remember, C stands for the number of Chocos. And F, the number of Flakers, must be less than 7,000. We've just got one more thing to add, and that's the non-negative variables. Both C and F must be greater than or equal to 0 because we can't have negative amounts of products. Diagrammatically, we create this and we end up with a feasible area, which is shown in pinky purple colour here. And that is the only production mix that we can make because we have to have less than 7,000, we have to have less than 5,000. We have a profit line, which we draw by putting a value in for the right-hand side, and we try to get to the maximum point for this because it's maximising our variables, so it'll be at one of the corners, the maximum point. In this case, it's at 5,000 for Chocos and 4,000 for Flakers. The computer solution will give us quite a lot of information. We don't actually need to draw this, and in fact we can't draw these if we have more than 2 variables. We had 2 variables with Chocos and Flakers, but more often it has 3, 4, 5, 6 variables. So from the computer solution, we can find out how many of each of the decision variables we should produce, how many Chocos and how many Flakers. We can find our optimal solution from the objective function. That means what is the profit that we make, or what is the cost if we were doing a minimization. We can find how much is left over from each of the constraints. That's known as your slack variables. We can also find the shadow prices, which is known as the dual price, and it's known as the unit of worth. So how much is it worth to have extra of one of our resources? And our resources are Chocos, Flakers, E114 and E320. The reduced cost tells us how much we have to reduce the cost or increase the profit on one of our products, Chocos or Flakers, in order for it to start being produced. And the ranges for the objective function and right-hand sides can be found from this. So the current solution will be valid within the ranges given for the objective function and the right-hand side values. So here's a management scientist package output, and it gives us quite a lot of that detail I've just discussed. So let's have a look at it now. First of all, we have our profit of 66,000 or £660. Then we have our optimal product mix, that's what it's known as, but it's the amount that we produce of each of our decision variables. C is 5,000 and F is 4,000. So we're going to produce 5,000 chocos and 4,000 flakers. The reduced cost tells us how much we need to increase our profit on so that we start producing C or F, or decision variables. You can see in this case both are 0, therefore both are being produced already, so we don't need to change the costs at all. The dual price tells us how much it's worth to buy extra of one of the constraints, so that's E320, E114, chocos or flakers. And the slack surplus tells us how much is left over from each of our resource constraints. So it's saying there are 15,000 grams left over of E114 and there are 3,000 grams left over of flakers. So let's do this in a bit more detail. What does the shadow price, dual price or unit of worth mean? They're all the same word. How much is it worth to have an extra unit of a constraint? So if we look at this, we look at the dual price column. Only 2 and 3 have values for unit of worth. The other 2 have slack values, so it's not worth buying any more of those because we already have some left over. So if we have a 0.8 for constraint 2, which refers to E320, it's telling us for every extra unit on that resource, E320, we would add 0.8 pence to the profit. So if we went up from 70,000 to 70,001, our profit would go up from £660 to... Similarly for constraint 3, our profit would go up by 2 pence for every extra choco produced. So if we had 5,001 chocos, we would be getting £660 and 2 pence. In terms of slack surplus, I've already mentioned there is a surplus of 15,000 grams of E114. That was our first constraint. And there are 3,000 flakers left over. In other words, we could have produced an extra 3,000, but other restrictions stopped us doing so. And the reduced cost column, both are 0, as I mentioned earlier, which means we don't need to change the profits of the chocos or flakers in order to start producing them. And now looking at the limits for the objective function range on the right-hand side, within the limit for C between 8 and no upper limit, we will stay with the same solution, the same product mix. With F, we can go between 0 and 5, and we will stay with the same solution. The same for the right-hand side values. If our current value for E114, 80,000, goes down to 65,000 or up to no upper limit, we will stay with the same feasible solution. And similarly for constraint 2, 3 and 4. So what does it mean to increase our objective coefficient ranges? What it's saying is if we change the number 10 pence and 4 pence to something else, then it will impact on our profit. But how much can we change these before it changes the number that we produce of each of the goods? It will always find a feasible solution. The only thing that would happen is that we produce a different amount of chocos and flakers, but we will always have a solution because we always have the same feasible area, and we would just move to another corner on the graph. If it's in 2 dimensions, we can draw it, but otherwise we can't. So I mentioned C can go between 8 and no upper limit, and F can vary between 0 and 5, and we remain with the same solution. Outside this range, we will just simply move to another product mix. So we might have, instead of 5,000 chocos and 4,000 flakers, we might have something like 3,000 chocos and 7,000 flakers. So here's the diagram. Basically, all that's happening is your profit line changes, where this is the profit line of the original question, and our optimal point was here. If the profit line changes to something like this, our optimal point would be here, and we simply move to a different corner of the feasible area. Right-hand side changes means we have more of a resource available. And if we have more resources available, it will add to our profits. But if we have too little resources, we might end up without a feasible area. And if we have too much, it might mean that we have a new solution. So what we're actually looking at is changing the 70,000 to maybe 70,001 or 70,002 or 80,000 or 90,000. But what impact will that have on our solution? So if we have a look at constraint 2, we can vary between 50,000 and 77,500, and we remain with the current solution. We will make chocos and flakers. Outside this, we may or may not have a possible solution. Just diagrammatically, that's saying if we change the number of flakers from 70,000 to 70,000 plus 5,000, it simply moves our constraint away from the origin in a parallel manner. So what's the answers to some of these questions? How many of each product should be made and what will be the resulting profit? We should make 5,000 of C, 4,000 of F, and our profit will be 66,000 pence or £660. We should have surpluses on constraint 1, which is E114, worth 15,000. And on constraint 4, which is flakers, which is 3,000. Our dual price tells us what it's worth for extra of a resource. If we have no slack or surplus left over, we might want to buy more. So it's worth paying up to 0.8 pence for extra of E320, which is constraint 2, or up to 2 pence for each extra choco that we can produce. So if we had 1,000 extra chocos produced, we could add 2,000 pence or £20 to our profit. If we have additional units of E320 available for 1 pence each, is it worth buying these units? The answer is no, because we would add 0.8 profit if we had an extra gram of E320, but it costs 1 pence and the cost is greater than the profit, therefore the answer is no. We also need to be able to interpret the Excel output. In fact, you might say that this is more important. This can simply be put into Excel. There are instructions usually within Excel on how to set this up. I've set one up just as an example, although you won't have to do this. Just showing you how easy it is. And the output I'm now going to show you and explain how it differs from the management science output. So let's have a look at this. We can see a recognisable figure of 66,000 or £660 being our profit. We should recognise now that we produce 5,000 chocos and 4,000 flakers. And we also should recognise that we have 15,000 grams of E114 left over and 3,000 grams of flakers left over. Now looking at this slide, which is the ones for our ranges for the objective function and the constraints. So this is slightly different to the management science output. The management science output said that flakers go between 0 and 5, whereas with the Microsoft output it says the current value is 4 and we can increase by 1 or reduce by 4. If we increase by 1, 4 plus 1 is 5, and 4 minus 4 gives us 0. The dual price is the same. The dual price, shadow price, it's known in this case, also known as unit of worth. So we're saying we should see the figures here. 0.8 for constraint 2 means we can, if for every extra gram of constraint 2, it will add 0.8 pence to profit. And for every extra gram, every choco we produce, it will add 2 pence profit. And the right-hand side values, we can see that the current value is 70,000 for constraint 2. We're allowed to go up to 70,000 plus 7,500, giving us 77,500 as the upper limit for constraint 2. and 70,000 minus 20,000 gives us 50,000 as the lower limit for constraint 2.